Hello everyone. Today I discuss about BSc first year semester 1, that is paper name is mechanics. Today I discuss about central force introduction and definitions and examples and features of central forces and conservation of angular momentum. These are discussing, and what is the central force and definitions and another ones and examples also. That is Newton's formulas is 3 laws of motion which gives qualitative and quantitative measures of forces. Different types of forces actually arise in nature. Basically there are 4 fundamental types of these forces depending upon the interaction of matter. That is, these are following these forces: nuclear forces and electromagnetic force due to electromagnetic interaction, and weak interaction forces and gravitational forces. These are 4 forces. The 2 forces are the short ranges of forces, and gravitational force and electromagnetic force are long range forces, and interaction is weakest. All the most bodies in the universe of a central forces, and gravitational force is conservative force and is an example of central force. This is the force general fundamental forces: nuclear force, weak interaction force, electromagnetic force and gravitational force. Okay, these are 2 forces is short ranges forces, and gravitational force and electromagnetic forces are long ranges forces, and interaction is weakest. And all the most bodies in the universe of a central forces, and gravitational force is a conservative force and is an example of central force. What is define of central forces? A central force is defined as a force which always acts on a particle or body towards or away from the fixed point, and whose magnitude depends upon only on the distance from the fixed point. Now this is the central origin O, this is the central of force, and that is x axis, y and z axis. Let us consider one particle, that is P, and OP is the distance of r. This is the position vector r bar. This is OP is equal to r is the position vector. This P is the particle, that is here central of this force. This force is attracting of the force and repulsive of the particle. So one particle is, this force is attractive, and another one particle is repulsive forces. So this is the central force, and this force is always body towards or away from this fixed point. This is the fixed point. This particle is, one is attracting and another term is repulsive. So that is the always acts on a particle or body towards or away from the fixed point, and choose this position, that is OP is equal to r bar, that is the position vector. This is the magnetic force depending upon the distance of the fixed point. This is fixed point, that is central of this point is called the central of force. Okay, what is the definition of central force? Central force is defined as the force which always acts on a particle or body towards or away from a fixed point, and choose magnitude depends upon only on the distance from the fixed point. So a central force and objective is a force that is directed along the line joining of the objective and the origin. This is origin is the center of the force, and P is the one particle. The force is attractive and repulsive. So that is body towards or away from this fixed point, and this is the distance between OP is the magnetic force. So that is OP is equal to R cap. So what is the central force of a particle P is defined as central force on a particle P expressed by this force, that is mathematically is represented of central force F is equal to R cap into F of R. Here F of R is a function of the distance of R, and R cap is the unit vector along the radius vector R of the particle with respect to the point, that is F is equal to R cap into F of R. This is the central force equation, F equal to R cap into F of R. That is central forces example is gravitational force and electrostatic force. These are 2 elasticity force. These are examples of the central force. First one is gravitational force of attraction between 2 forces. Let us consider 2 mass. This objective is mass is m1 and another objective mass is m2. This is m1 and m2 is the, these 2 objectives is attracting these forces. This is the m1 and m2 is distance of the r. Here force is proportional to the big mass m1 and the small mass, that is m2. F proportional to m1 and m2, and that is the distance between r, that is inversely proportional to the square of the distance, that is F proportional to 1 by r square. F proportional to m1 m2 and F proportional to 1 by r square. Totally F proportional to m1 m2 by r square, that is F is equal to minus g into m1 m2 by r square. G is the gravitational force, this is the gravitational constant. F is equal to g into m1 m2 by r square. Here negative sign is indicating they attract to these forces. So that is F is equal minus g m1 m2 by r square. This is the gravitational force of this attractive between two masses, that is F proportional to 1 by r square. Here also substitute the central force value, that is F proportional to 1 by r square is we get. So F is inversely proportional to the square of the radius, that is the gravitational force of attracting between two masses. And another example is central force, electrostatic force. This is between two charges, similarly same as this is two charges, that is q1 and q2 charges. This is the distance of r, and this force is proportional to this q1 charge and q2 charge, and force is inversely proportional to the square of this distance, that is F proportional to 1 by r square. So similarly these two equation, F proportional to q1 q2 by r square, F is equal k into q1 q2 by r square. K is the constant. So k is equal to what the value, that is 1 by 4 pi epsilon naught. Here epsilon naught is the permittivity of the free space. So here k equal 1 by 4 pi epsilon naught, then substitute this value, F is equal 1 by 4 pi epsilon naught q1 q2 by r square. q1 q2 by 4 pi epsilon naught, that is constant. So F proportional to 1 by r square. So that is the central force of the example of electrostatic force. Next, features of the central forces. The general form of the central force, that is F is equal to r cap into F of r. F of r is the function of the distance of r of the particle from the fixed point, and r cap is the unit vector along the radius vector r of the particle with respect to the point, and equation of the central force, that is F is equal to r cap into F of r. The central force is the conservative force. Conservative force means the work done by a force is moving a particle from one point to another point in independent of the path followed. That is the conservative force. That is called the central force is the conservative force of the one of the characters. And another one, under a central force, torque acting on a particle is always 0. That is torque is equal to r cross F. So one axis is rotating in the axis, that is the torque r cross F. So that is torque is equal to 0. So under a central force, the angular momentum of a particle remains also constant. These are relating to this torque and angular momentum. So both are that is equal to, and torque equal to 0, that is torque is equal to dou L by dou T. The L is the constant. L means angular momentum. Angular momentum of the particle is remains constant. And another one, that is F of r less than value, then the central force of the attractive forces, and that is the value is negative. So F is equal to negative value, we get F of r greater than equal to 0, the central force is repulsive force, that is the value is positive value. These are characteristics of the central forces or features of the central forces. This is general form of the central force. F is equal to r cap into F of r, and here F of r is the function of the distance r of the particle from the fixed point, and r cap is the unit vector along the radius vector, that is r of the particle with respect to the point, and central force is the conservative force, and central force, the torque acting on a particle is always 0, and the central force is the angular momentum is also constant, that is F of r less than or equal 0, that is the central force is attractive, that force is negative value, and F of r is greater than 0, the central force is repulsive, that is the force is positive value. Okay, here this is the central force definition. And conservation of angular momentum. According to this law, if no external torque acting on a body rotating about the fixed point, the angular momentum of the body remains constant. When a body is rotating about an axis, the torque acting on it is given by torque is equal to R cross F, that is then substituting F equal to central force, that is F is equal to R cap into F of R, then this is simplification, that is torque is equal to 0, that is torque is equal to dl by dt is equal to 0, but torque acting on a body is equal to the rate of the change of the angular momentum, that is equal to constant, L is equal to constant. So particle rotating about axis due to the central force, the angular momentum is constant, both it is the direction and dimension. This is called the conservation of angular momentum. And what is the examples of the conservation of momentum? Motion of a planet is in it is orbit. So the earth moves around the sun under a central forces which is always directed towards the sun. Okay. And another one is scattering alpha particles by a heavy nucleus. These are examples of the conservation of angular momentum. Conservative force. A force is said to be conservative when the work done by the force is moving of a particle from A to B is independent of the path followed between A to B is the same as all the paths, and the work done depending only on the particle is initial position and final position. The work done by the conservative force along the closed path is that is equal to 0. That is one example of this. Let us consider a particle is taken from point A to B and another one B to A. This is total work done is equal to 0. That is the conservative force. That is WAB is equal to, that is the force integration of A to B F of F, and another one B to A work done WB to A, that is integration of B to A F. So here that is both are cancelled, then that is equal to 0. WAB plus WBA is equal to 0. So total a particle is taken from A to B through the path that is B to A second path, this totally work done is equal to 0. That is the conservative force. Conservative force has a negative gradient of a potential energy. So conservative force, the work done against the center force is equal to the increasing in potential energy of the body. The potential of a body on the earth is 0 when the body is lifted to certain height against a gravitational force, and increasing the potential energy takes place. Let us consider u of x comma y comma z of the potential energy function due to the central force field. The change in potential energy is du is equal to dou u by dou xi plus dou u by dou yj plus dou u by dou zk into dxi plus dyj plus dzk. So this is the potential energy. The work done against the central force is equal to the change of the potential energy, that is change of the potential energy dou u by dou t. Our x direction is x and y z both are directions. The work done against the central force is equal to the change of the potential energy. Du is equal minus f dr. So that is f is equal to fxi plus fyj plus fz k. I, j, k terms the vectors x axis direction, y direction and k direction. So here position vector r is equal to xi plus yj plus zk, you know. So that is differentiating of position vector dr is equal to dxi plus dyj plus dzk. So you can this is dr value and f value is substituting in equation 1. Du is equal to minus fxi plus fyj plus fzk into dxi plus dyj plus dzk. Then I into I product is 1, I into j is equal to 0, I into k is equal to 0, and similarly j into I is also equal to 0, j is equal to 1 and j dot k equal to 0, and similarly k term is multiplying in all terms. K dot I equal to 0, k dot j is equal to 0, k dot k equal to 1. This is multiplication du equal to minus fx dx. This is minus on both and multiplying in other terms x, y, z terms also. Minus fx dx minus fy dy minus fz dz. So here du means that is x term, y term and z term. Du of x plus du y plus du z is equal to minus fx dx minus fy dy minus fz dz. So this equation corresponding terms in LHS or RHS we get equal. Then x terms and y terms and z terms are both are LHS terms and RHS terms equal to. So that is fx is equal to dou u of x by dou x. Here dx term, that is x term, and y term is equal, and z term is equal, that is minus fx dx is equal to dux. So fx is equal minus dou u by dou x. Dou x is equal to outside, then that is the denominator. So fx is equal to minus dou ux by dou x, fy equal to minus dou u by dou y, fz is equal to minus dou u by dou z. So this value f is equal to minus dou u by dou x I plus dou u by dou z plus dou u by dou z into k. This combination of this vector form. So here you can write fx, fy, fz. So you can write f is equal minus dou u by dou x I plus dou u by dou y into z plus dou u by dou z into k. You can write del is equal to I into dou by dou x plus j into dou by dou y plus k into dou by dou z. That is the negative gradient of the potential energy. This del value is substituting in this above equation. So dou by dou x, dou by dou y, dou by dou z. You can write minus del. Here minus is term minus, that is minus del u. F is equal to minus del u. This is the conservative force of a negative gradient of the potential. This combination of this equation can once again explain that this equation, that is very important, conservative force as a negative gradient of a potential. Here the change of potential du is equal to dou u by dou x I plus dou u by dou y z plus dou u by dou z into k, dxi plus dyj plus dzk. This is multiplication, and that is the, you can term central force equation. The work done against the central force is equal to the change of the potential energy, du equal minus f into dr. So that is, you can write f is equal to fxi plus fyj plus fzk, and dr is the position vector, that is r is equal to xi plus yj plus zk. You can derivation dr, that is equal to dxi plus dyj plus dzk. So f value and dr value in substituting in equation, then that is the simplification this equation, that is compared to x term and y term and z term, that is fx is equal minus dou u by dou x, y term is fy is equal minus dou u by dou y, and fz is equal minus dou u by dou z. And this is combination of this vector, f is equal minus dou u by dou xi plus dou u by dou y z plus dou u by dou z into k. So that is the del operator is substituting in this equation, f equal to minus del dot u. This is the conservative force as a negative gradient of the potential energy. One example of the curl of a conservative force. So you know conservative force, that is equal to 0. So the negative gradient of the force f is equal minus del dot u. So here curl of a conservative force, what is the conservative force is equal to 0. So that is prove that value. Curl of f means del cross f. What is the f means? Minus del u. Is negative sign is imaginary, that is neglecting value, that is equal to del cross del u, that is del means I into dou by dou x plus j into dou y plus k into dou by dou z. So u is the multiplication, I into dou u by dou x plus j into dou u by dou y plus k into dou u by dou z. What is the formula? Del cross f or curl f is equal to det of I j k dou by dou x, dou by dou y plus dou by dou z, x term, y term and z term. Here x term means, that is I term, j term and k terms, x differentiating and y differentiating, z differentiating. Here substitute this I term. So del cross f. So this is f means I into dou u by dou x, j and k terms. So substitute this I term dou u by dou x, and j is the dou u by dou y, and k is the dou u by dou z. This is cross multiplication, this is the equation. I term is closed, then this is the cross multiplication, y term and z term, and that is dou by dou z, dou y into dou u by dou z. So simplify dou square u by dou y dou z. This is cross multiplication, k and j terms. So dou by dou z into dou u by dou y. So this is multiplication, dou square u by dou y and dou z terms, plus and z term is also. We can write z term is close, then cross multiplication, this is lower to upper. This is dou square dou by dou x, dou u by dou z. So this is multiplication, dou square u by dou x into dou z, minus this is dou by dou z, and again dou u by dou x is multiplication, and that is dou square u by dou x dou z. Similarly k term is close, and that is x term, x and I and j is the cross multiplication. So k is the close, dou by dou x, that is dou u by dou y, that is multiplication of dou square u by dou x dou y, and again dou y dou by dou y, this is into dou u by dou x, this is cross multiplication, that is dou square u by dou y dou z. This is dou square u by dou y dou z, and here also y term and z term. This is y term and z term, this is plus and this is minus, that is both are cancel. Here also dou square u by dou z dou x, this is also dou z dou x, this is the cancel, and k term is also cancel, x y terms is, so that's why both are cancel. So that is del cross f is equal to what? 0. Curl of a negative gradient of a conservative force is equal to 0. This is the curl of a conservative force, one of the example of the negative gradient of the potential energy. Again explain to central force. What is the definition of central force? A central force is defined as a force which always acts on a particle or a body towards or away from a fixed point, and choose magnitude depending only on the distance of the fixed point. That is called the central force. This is the central force, and let us consider one particle, that is P. This is the distance of r cap, that is OP is equal to r cap. This is particle is attracted to the force and repulsive of this force. This is the fixed particle, that is the fixed particle is that is central of force. Okay, so this is both are particles is attractive and repulsive of this, away towards and always acts on a particle or body towards or away from a fixed point, that is the called as central forces. OP is the distance of the magnetic force, that is r, only that is the distance depending on the magnitude, depending upon only on the distance from the fixed point. So that is the central force. So central force is mathematically is represented F is equal to r cap into F of r, that is F of r is the function of the distance of r, and r cap is the unit vector from the fixed point. R cap is the unit vector along the radius vector r of the particle with respect to the point, and that is central force F is equal to r cap into F of r. Example of the central force, that is the gravitational force. Gravitational force is the two masses. So this is attractive force, F is proportional to m1 and m2. These two masses is distance of r, that is inversely proportional to the square of the distance, that is F proportional to 1 by r square. So F proportional to m1 m2 by r square, that is F is equal to g m1 m2 by r square, and F is equal minus g m1 m2 by r square. Here g is the gravitational constant and m1 m2 is the two particle masses, that is m1 and m2. R is the distance of the these bodies, distance of r. So F proportional to m1 m2 by r square, that is F is equal minus g m1 m2 by r square. G is the gravitational force. And similarly you can substitute the central force F is equal to F of r into r cap. You can write simplification, that is F proportional to 1 by r square, that is the gravitational force of attractive between two masses. And another one is electrostatic force between two charges. Let us consider two charges, that is q1 and q2. This is the F proportional to q1 q2 charges, and this is the distance of r, and that is inversely proportional to the square of the distance, that is F proportional to 1 by r square, F proportional to q1 q2 by r square, and F is equal to k into q1 q2 by r square. K is the constant and k is the value of 1 by 4 pi epsilon naught. 1 by 4 pi is that is 4 is constant value, and pi is also 3.14 value, that is also constant, and epsilon naught is the permittivity of the free space, that is the value of 25 into 10 to the power minus 32, that is the value substituting, that is the k value is equal 1 by 4 pi epsilon also, that is the whole number is the constant value. So F is equal to, that is 1 by 4 pi epsilon naught q1 q2 by r square. Here then substituting central force equation, and F is equal to F of r into r cap, then that is simplify, F is proportional to the 1 by r square. This is the electrical force between the two charges. This is the central force, and central forces characteristics are features of the central forces. The general form of the central force F is equal to F of r into r cap. F of r is the function of a distance r of the particle from the fixed point, and r cap is the unit vector along the radius vector r of the particle with respect to the fixed point. And another one, central force is the conservative forces. Under a particle is always 0, and another one, under a central force the angular momentum of a particle is equal to constant, and F of r less than or equal 0, then the central force is attractive and the force is a negative value, and F of r is greater than 0, the central force is repulsive and the force is positive value. This is the central force, and that is the definition, and these are very important questions. Thank you.